Pump muff part 2. So today we're talking elevation pressure. What does that mean? Gravity. Is the nozzle above or below the pump, and by how much? That's it. I don't care how long the line is. I don't care how big the line is. I don't care. All we're talking about in this little piece is gravity. So why does gravity matter that much? Water is heavy. Every gallon of water is about 8.3 pounds. Think of it like moving a weight. This takes a certain amount of energy, and if I'm moving it up a foot, it takes a little more. If I'm moving it down a foot, a little less. So if my input and my output are at about the same level, it takes a certain amount of energy to expel that water. Now if my output is higher than my input, it takes more energy. If you're pumping up 1 foot, that's elevation loss of 0.5 psi. Actually, it's 0.434 psi per foot of elevation. Yeah, we're gonna round that up to 0.5. Then if the output is lower, well, I mean, that just did some of the work for me anyway. Way easier. If you're pumping down 1 foot, that's elevation gain of 0.5 psi. So your equation is your number of feet times 0.5 psi. If you're eyeballing a vertical distance on scene, you're probably not going to go, that looks like 17.5 feet. It's easier to guess it in tens. If you're looking at a residential building, it's about 10 feet per floor. So if you've got 10 feet times 0.5, it gives you 5 psi, which gives us easier math. Let's say there's a line going up the ladder to the second floor. That's 10 feet above, so it needs an extra 5 psi of pressure. Let's say we've got another line going to the basement, going down 10 feet, that needs 5 psi less. Or let's say your nozzle is 20 feet downhill from your pumper. That's 10 psi less you need to send. But what if the hose goes up 3 feet and down 5 feet and up 10 feet and down 2 and up 6? Good news, you don't have to calculate all that. So the interesting bit is if it goes down and it goes up, they cancel each other out. You can see the water's not going anywhere. And even if I push up this bit in the middle so it's going up and down, it still doesn't change anything. So what happens on the way doesn't matter. What matters is the difference. When we're talking output from the pump, it could go up and down and it does not matter. It can go anywhere it wants. The only thing that really matters in the end is from the nozzle to the pump. What is this difference? And is it up or is it down? Unless, of course, you have a kink, but that's not what we're talking about right now. Bottom line, for every 10 feet above the pump the nozzle is, you need to give them an extra 5 psi. For every 10 feet below the pump they are, you need to back off 5 psi. We need to make sure we get the right pressure to the nozzle for the safety of them and to best fight the fire.